Welcome to Mpaiso Lately. This is biology. We are going to look at enzymes, but our lesson is mostly based on experiments. The main topic for today is the effects of temperature on enzymes activities, right? The effects of temperature on enzyme activities. This is whereby we are going to look at the effects of low temperature, high temperature, and optimum temperature on enzymes activity. We are told that when you subject your enzymes to low temperature, our enzymes will be inactive. When they are subjected to an optimum temperature, they actually tend to work best, and when we subject them to high temperature, these enzymes are to be denatured. So this is what we are looking at in this experiment. Now the aim of this experiment is we want to show that enzymes, they are actually sensitive to temperature. And then the second aim is to prove that enzymes are denatured when they are subjected to a very high temperature. And then lastly, we want to indicate that every enzyme actually works best when they are subjected to an optimum temperature. Okay, so these are the three aims that we are going to look at, or rather these are the objectives that we intend to answer by the end of this lesson. All right, so in our experiment we are actually having 4 test tubes. Now in our 4 test tubes we have the same content of saliva that contains amylase, and also we have starch plus iodine solution. Now the only difference is that these test tubes, they are actually subjected to different temperatures. Test tube A is subjected to 10 degrees Celsius, whereas B is subjected to 20 degrees Celsius, C is subjected to 35 degrees Celsius, and then D is subjected to 90 degrees Celsius. But the content that we have in each test tube is the same and it's equal. So in test tube A, we have saliva that contains amylase, and then we have starch. Test tube B, it's the same thing. C, the same thing, and then so is D. Alright? So now, why do we have amylase, or rather, why do we have saliva and starch? We know that enzymes are specific. Now, because enzymes are specific, amylase can only break down starch. And where do we get this amylase? Amylase is contained in the saliva, right? So amylase can only digest starch. This is why we have amylase and starch. And then another question is, why do we have starch plus iodine? When you did food test, you know that iodine tests for the presence of starch, right? So iodine is yellowish to brownish in color. And then when do you get a positive reaction? Starch, or rather when starch is present, your iodine solution will change from yellow to blue. Okay, so when starch is present in a food sample, we are told that our iodine solution will change from yellowish, or rather brownish, to blue. That is to indicate that starch is actually present in your food, in a certain product, or rather in a certain food sample. Okay, so in short, we are using starch, and we want to be sure, is it true that starch is present in our test tubes? And if starch is present, we still want to know what happens when amylase digests starch. Will starch still be present? So because of that, we are using iodine solution to test for the presence of starch. All right, so our test tubes are subjected to different temperatures. Test tube 1 is in a water bath that is actually maintained at 10 degrees Celsius. Test tube B is in a water bath that is maintained at 20 degrees Celsius. So is C and D. All right. all these test tubes, they are placed in a water bath, and then their temperatures are maintained. We don't want the temperature to go above 10, right? We want to maintain our temperature to be constantly at 10, and then this one should be constantly at 20, 35, and 90 degrees Celsius. All right, so when we are saying water bath, for example, this is when you have your test tube that contains amylase and starch, and then you are putting it in a water bath. Water bath, it's more like this is a container that contains cold water. All right, now our cold water is maintained. This your normal water bath has a temperature knob, so there's a knob that you'll be maneuvering to ensure that, okay, right now the degrees, or rather my temperature should be at 0 degrees, or rather my temperature should be at 10 degrees, and then it will be at 10 degrees for the period you are running your experiment. All right, so this is what a water bath is. So test tube A is in a water bath that is at 10 degrees Celsius. Test tube B is in a water bath that is maintained at 20 degrees Celsius, and so forth. All right, so let's look at the results. What is it that we should expect at the end of the day? What will happen? Now, because test tube A is subjected in ice water, this is low temperature. Now, because this is low temperature, we know that our enzymes, they will be inactive. Now, because our enzymes, they are inactive, these enzymes, which is now amylase, they will not break down starch. All right, they will not break down starch. Now, because they are not breaking down starch, our solution will remain blue. Or rather, if they are breaking down starch, this is happening, but it's very slow. Okay, so because the process is slow, our solution will still remain blue because starch is still present. Now in test tube B, um, we are actually increasing our temperature by 10 degrees Celsius. All right, so we increased our temperature by 10 degrees Celsius. Now, because we increased our temperature by 10 degrees Celsius, we should know that our enzymes, they will start to work, but they will actually be slow. All right, they'll be slow as compared to how they will work in test tube C, but they'll be fast as compared to test tube A, because we increased, so we doubled the activities. Okay, whereas in test tube C, this is actually warm temperature, so this is the optimum temperature. Amylase is mostly likely to work best at an optimum temperature. Now, the optimum temperature of amylase, it's 35 degrees Celsius according to the diagram. So it's 35 degrees Celsius. Now, because our enzymes are subjected at an optimum temperature, these enzymes, they will break down starch very fast. So the reaction will be very fast in test tube C. And then because now your enzymes are breaking down, or rather because your enzymes broke down, or rather they digested starch, that means that your solution, it will change from blue to yellow. Why is it changing from blue to yellow? It's changing from blue to yellow because your test tube does not contain starch anymore. All right, your test tube does not contain starch anymore. This starch was digested by amylase, hence it will change from blue to yellow. Whereas in test tube D, we are seeing that our test tube is subjected to 90 degrees Celsius. Now 90 degrees Celsius, this is a high temperature. Now because this is a high temperature, our enzymes will be denatured. Now, because our enzymes are denatured, these enzymes, they are not working anymore. Because they are not working, amylase will not be able to digest on starch. Now, because your starch is not digested, your solution will remain blue to show that starch is still present. Okay, so that is it in short. Now let's go to our results, our table. Let's quickly go through again. Now, when do we get a positive reaction? we are told that a positive reaction is when, sorry for that, a positive reaction is when your solution when your solution changes from blue to yellowish, or rather brown, or rather it discolorize. Okay, that is to show that your starch was somehow digested. Now, because it was digested, your solution will change from blue, and then it will go to yellow. If not yellow, this can be brown. If not brown, it can be your solution will be discolorized. That is to show that your enzymes, they were somehow working. Okay, so let's see what happens in each test tube. Now, in test tube A, we are told that this is the slowest change. All right, test tube A, the changes are very slow. The reason to why your changes are slow, it's because of low temperature. And then in test tube B, we are told that our solution, it will change from blue, and then this solution will be discolorized. But however, this process is very slow. The reason why our solution is being discolorized, it's because we doubled the activities of our enzymes. We doubled the temperature. Now, because we doubled the temperature, we increased the temperature by 10 degrees Celsius, the activities of our enzymes also doubled. Now, this is actually telling us that your amylase, or rather amylase in test tube B, is somehow starting to digest starch. All right, and then in test tube C, we are told that the solution, which is blue in color, it actually disappears. So the blue color is changing quickly. Now, because this blue color is changing quickly, we can therefore conclude that test tube C is actually subjected at an optimum temperature. Now, because it's subjected at an optimum temperature, your enzymes are working best, such that your amylase is breaking down starch very fast, or rather quickly. And then in test tube D, there is no change at all. Now, because there is no change, our solution will remain blue. Let's interpret our results. Now, explaining our results, we are told that in test tube A, which is subjected at 10 degrees Celsius, there is no, or rather the reaction is very slow. Now, the reason why the reaction is very slow, it's because the test tube is subjected to low temperature. Now, because this test tube is subjected to a very low temperature, we are told that the activities of our enzymes, they tend to be slow, or rather our enzymes, they are inactive, they are not working. All right, whereas in test tube B, we are told that test tube B is faster compared to test tube A. Test tube B, the reaction that is going on in test tube B is faster compared to test tube A, but however, it's low as compared to test tube C. The reason to why the reaction is faster as compared to test tube A, it's because high temperature increases the speed of the activities of our enzymes. Remember, we were 10 degrees Celsius and then we moved to 20 degrees Celsius. This means that we increased by 10 degrees Celsius. Now, because we increased by 10 degrees Celsius, we have increased the temperature. Now, increasing the temperature increases the activities of our enzymes in test tube B. All right, now because we have increased the activities of our enzymes, that means that our amylase will start to break down starch. All right, so the activities of our enzymes have doubled. By the reaction that is occurring in test tube B, it's not fast as compared to what we are about to see in test tube C. All right, so now moving on to test tube C, we are told that in C, this is where you are mostly likely to observe fastest change. The reason why you are observing fastest change, it's because test tube C is subjected to 35 degrees Celsius, which is the optimum temperature for salivary amylase. All right, so in short, we are told that test tube C is subjected to an optimum temperature because now test tube C is subjected to an optimum temperature, we are told that our amylase, our enzymes, they work best at 35 degrees Celsius. Now, because they work best at 35 degrees Celsius, these enzymes, they will be able to digest starch such that your iodine will not be, or rather the solution, it will not be blue anymore. The reason why this solution will not remain blue is because starch was digested. Starch is used up. It's not there anymore. Now, because starch is absent, your iodine solution cannot remain blue. So it will change its color from being blue to yellow. All right, that is to show a positive reaction. So we are seeing a positive reaction in test tube C. And then in D, we are told that there is no reaction. The reason why there is no reaction is because these enzymes, they are denatured. So test tube D was subjected to a high temperature of 90 degrees Celsius. Now, because this is very high, these enzymes, or rather amylase, will be destroyed. Now, because this amylase is destroyed, your amylase will not be able to digest starch. Now, because your starch is not digested, your iodine solution, or rather the solution in our test tube, it will remain blue to show that starch is still present. Okay, so this brings us to the end of our lesson. So let's summarize what we said, or rather let's see if we have answered the M, or rather the objectives of our lesson. We said that we want to see whether enzymes, they are sensitive to temperature, and yes, we can therefore now say that yes, indeed, enzymes are sensitive to temperature. As you are changing the temperature, we saw that when we changed the temperature from 10 to 20, our enzymes started working such that test tube B was discolorized. From being blue, it was discolorized. And then from there, as we kept on increasing the temperature, we saw that in test tube C, these enzymes, they started working best, and then it completely changed from blue to yellow. And then in D, we are seeing that if the temperature is way too high, these enzymes, they'll be denatured. So yes, we can therefore say that yes, it's true that enzymes, they are sensitive to temperature. All right. And then the second objective was to prove that, to see whether is it true that when you subject enzymes to a very high temperature, these enzymes, they'll be denatured. And we are seeing that in test tube D. Test tube D is subjected to a very high temperature, and now because test tube D is subjected to a high temperature, we are seeing that amylase is not digesting starch anymore. Now, because starch is not digested, our solution will remain blue to show that starch is still present. Okay, and then lastly, we wanted to prove, or rather, the objective said that is it true that enzymes tend to work best when they are at an optimum temperature, or rather at their optimum temperature, which is true. We are seeing that when amylase is at an optimum temperature, which is in test tube C, these enzymes, they are working best. They are digesting starch, and because they are digesting starch, our solution will change from blue to yellowish. That is to show that these enzymes have digested starch, so which is a positive response. Okay, so this brings us to the end of our lesson. If you like our lessons, or rather if you have enjoyed the video, please do subscribe to our channel for more videos. We'll be uploading more videos as from now on. All right, at least every day, if not every day, every after a day or so. So in order for you to be notified, please do subscribe to our channel. All right, if you have any questions, please do comment below. If you feel like there's a unit that you want us to tackle, please also comment below, and then that will be considered. Right,